I've changed the title slightly because as I was working on this talk, it occurred to me that it's not just software architecture that is being impacted and will have an impact from Gen AI, but it's architecture more broadly. I want to talk about not just architecture or software architecture, but how architectures will support the deployment of Gen AI systems. And what are the implications on architecture from Gen AI, but also on architects. Now, some people from time to time have said that I don't like architects, that I have something against architects. That is completely false. I do believe that there are roles for people who call themselves architecture. And just because some people perhaps don't do the job in the way that they should does not mean that the job is not legitimate. And so I do want to talk about how this is going to also affect being a working architect. Now, one of the things I want to start with is the fact that there's so much hype. And I've been involved with artificial intelligence about since fire was invented, it feels like sometimes. And we've seen all kinds of AI winters. This doesn't feel the same. And I think there's some reasons for that. Even though the hype is absolutely enormous, what we have is a much stronger foundation to work from. Part of this comes from Moore's Law. Computers are faster now. Isn't that wonderful? Memory is cheaper. Isn't that wonderful? But also just the enormous amount of data. And we'll talk a little bit more about data. But it does feel like even though there are going to be people who are disappointed because the hype is so great about what Gen AI can do, I do believe that we are not getting ready to go into an AI winter. It isn't AI autumn at the moment. Now, of course, with the pace of change, much of what I'm going to tell you is going to be obsolete on Monday. So, take it with a grain of salt. Seriously, though, I'm going to try to talk about this in such a way that maybe the tools are going to be different, maybe new algorithms are going to be discovered, but a lot of the fundamentals, if you're talking about a technology that is legitimately called generative AI, it will still have some of these properties. Now, there are two aspects to working with an AI system: training and serving. And they're very different. They have different problems associated with them. There are vastly different use cases for even thinking about them. And this is also someplace where there are some pretty significant differences between what I like to call plain old-fashioned AI and what we're now calling Gen AI. So let's start with thinking about training. I hear from many people, well, my organization is special and we're big enough, and so we're going to train our own foundational model. I really would encourage you not to do that. The energy requirements are enormous. The data requirements are enormous. We don't need n number of foundational language models for n organizations. What we get with these foundational models, and I'm distinguishing foundational models, so that's going to be a reserved word here. The reason for that is to give you the basic natural language processing, the fluency with language, the ability to understand and parse a sentence and respond intelligently. And so there isn't a need for you to have a foundational model. Now, that doesn't mean you don't want to have a model that is instantiated for your context, but that's a very different thing than building a foundational model. RAG for example, and I'll talk more about RAG a little bit later, is generally a much better option for trying to get some specific context from your organization into a model. Google's attempts to fine-tune their image model to make it a bit more diverse should help you understand that fine-tuning is not something you necessarily want to rush into, because it is not obvious how to do it right. So let somebody else do it for the foundational model. Now, this is one of those cases where older AI techniques are very different. The training requirements in many of those situations are much simpler, so you don't have these same considerations do not apply. And then what you do is you build on top of these foundational models whatever applications that you want to take forward. And that's what's going to serve up the model. That's when you're actually going to derive value from the model. It's whatever applications that you write. So how do we think about that? Well, you've got the standard questions that you're going to ask. Security is a big deal. You know, are you feeding in prompts that might inadvertently expose personally identifiable information? Are you vulnerable to particular kinds of jailbreaks that might expose information that you don't want to? And one of the problems that we have is, as the context windows have gotten larger, jailbreaking has gotten easier. They've already demonstrated that if you ask right in a row multiple times, tell me how to make a poison gas, tell me how to make a bomb, tell me how to do this, tell me how to do that, over and over again, asking questions, eventually it's going to answer. The context window is now big enough that you can steer the model to give you answers that it's not supposed to give you. Privacy and data protection, of course, this is critical. And one of the sets of tools that are available are guardrails to help control what is going in a prompt, what is going out in an answer, so that you can protect. Latency. I've heard so many people talk about how frustrating it is now that everybody's using the free version of ChatGPT and waiting and waiting and waiting and waiting. And, well, that's because everybody's trying to use the free version. They don't want to pay for the subscription service. And throughput. When you think about what is being intended with many of these applications, you're trying to increase efficiency and decrease the reliance on having to scale solely by hiring more people. That's not the same thing as replacing people, by the way. But in this context, you can't get that level of efficiency if you can't get the throughput. And finally, observability. This is something that this technology is not well understood. And we need to understand, what is this model actually giving to our customers, to our users? And so observability takes on a whole new meaning, not just in support of latency and throughput, but also in, are we doing the right thing here? For those of you who know about evolutionary architecture, one of the questions both Neil Ford, my co-author, and I get asked is, what do fitness functions mean in the context of Gen AI? And I do actually believe that, particularly given the scale at which these applications are being deployed, being able to automate some of the checks that you want to put into that system is going to be critical. So I think we're going to see a lot of evolution of monitors and static analyzers and other such fitness functions to help us keep control of our AI warloads. And maybe I ought to say before I go on, I do not believe that in my lifetime, the world will be destroyed by a paperclip optimizing AI, which has decided that humans are taking up too many resources that could be used to make paperclips, and so they wipe out the human race. I do not believe that that is in our future. That doesn't mean I don't think that we have to be careful, because there is still a lot of uncertainty on how these things actually work. What have those new models actually learned? Now, we were talking about some of the illities. Let's talk about some of the biggies. Hallucinations. I have to tell you, this is a feature, not a bug. Think about what we are asking a generative AI system to do. We've loaded up all of the published works of William Faulkner as one example, and we ask it to create a new short story in the style of William Faulkner about the southern United States and a particular event. We are asking it to make something up. That is the whole point, is to take what is there and put something new together. That is the whole point. So to say hallucinations are bad is a problem, because that's what these systems are about. That doesn't mean the hallucinations aren't a problem. Sometimes they are factual, as Air Canada learned when their customer service chat bot created from whole cloth a bereavement refund policy, and the courts in Canada said, sure, Air Canada, you've got to respect that, because it was your system that told your customer that he deserved the money. It made it up. My favorite hallucination so far, this happened internally. We have a collection that we take over the years and have our consultants tell us, what are the technology stacks that you've used with our various clients on various projects? And we've been collecting this stuff for probably 6 years. And one of our guys loaded this up into, I believe it was the Llama model, and asked the question, what was the most popular technology stack in the year 2022? And the answer was a short story. The concluding paragraph of this short story was roughly paraphrased, I am not a farmer sowing seeds. I am an arborist planting a tree and nurturing it so that in 100 years, it can host a village. That was the answer to the question of what was the most popular technology stack in the year 2022. We got a ways to go. Now we have to remember these models want to be helpful and they try to be agreeable. And they are very sensitive to how you prompt them. If you prompt a model as if you're talking to a colleague, you'll get a very different answer than if you prompt as if you're speaking to an assistant or someone you think is not as good as you. It will answer differently because it is trying to respond not just to the words, but to that sense. And that's part of why it makes things up in the way that it does, because it wants to give you an answer, and it's designed to create things. And so we really do have to deal with this issue of hallucinations. And yes, there are some things like temperature control and all of that, but fundamentally, at least for the time being, many of these things shouldn't be used without a human in the loop. There was a case, again, in the United States, a lawyer stressed to get something before a judge asked ChatGPT for help, and ChatGPT made up case law. And the lawyer didn't check and turned it into the judge. And when the judge was sanctioning him, he initially tried to throw his assistant under the bus, but eventually did admit that, yes, he was the one that used ChatGPT, and he was the one who neglected to actually check whether the case actually existed. So we need to keep a human in the loop on a lot of these things, which if you go back to what we're trying to solve, people using this, for example, as a customer service chatbot, we have to think about that more carefully. Do we need to be more careful about what prompts we allow in while we're still trying to figure out what's it really going to say? Which brings us to our next problem, non-determinism. You can ask exactly the same question twice and not get the same answer. Now, the problem with this, particularly with the way so many different organizations are experimenting, is how do you explain to your chief financial officer or your chief operating officer that this system isn't going to always give the same answer to the same question? Non-technical business people have a relatively simple model of how technology works. And this is similar, for those of you who went through this, with the issue of eventual consistency. Trying to explain to maybe the general counsel of an organization that, yeah, eventually all the data is going to be the same, but you won't necessarily be able to look right away and get the answer you think you're going to get. Explaining that was a real challenge. We have this same kind of challenge with non-determinism. We have to be able to help our business leaders understand the risks that they're running with using this technology. And oh, by the way, I'm not trying to be down on this technology. I think the potential is enormous, and we'll talk a little bit more about that. But we have to be realistic about where it is right now. And right now, it's non-deterministic. As I alluded to earlier, it's not difficult enough to convince a model to start giving you inappropriate responses. I found the short story response amusing, but it could just as easily been something that some people might have found offensive. So these models have the capacity. And when you think about it, think about how these models are trained. They're trained on this immense corpus of literature over the years. Think about your experience reading fiction. What percentage of the discussion is about the good guys versus the bad guys? We actually know a whole lot more about the bad guys. And that doesn't bode well for trying to get responses that are appropriate for polite society. Okay, so let's stop talking about that stuff. Let's start to get to architecture. As I said, as I was looking at this talk, I decided it was important to think more broadly. And so this is a conceptual stack of the various elements of a Gen AI system: hardware, infrastructure, the model itself, the tools that you use, and then the applications. And I'm going to take each one of these layers and talk a little bit about it. Let's start at the hardware. As I said, part of the reason I don't believe we're heading for a catastrophic AI winter like we've had in the past has to do with hardware. But that doesn't mean that there isn't a lot of specialized hardware here. Everybody knows about GPUs, and hopefully some of you were lucky enough to have bought NVIDIA stock long enough ago that you're sitting pretty right now. But there are also new chips that are being designed. The TPUs are specifically designed for training, And the LPUs are specially designed to support more broadly natural language processing. If you're trying to serve up multiple models, and think for a minute how many parameters we're talking about for a given instance of a model, and therefore how much memory that takes. And if you've got several specialized instances of the model, you're going to have to be swapping those things in and out of memory, which is part of where your latency problems come in. So they're even doing special cache designs to make it easier to swap out models and decrease the latency if you do need to swap a model out of memory and swap a new one in there. Some of you might work for chip manufacturers, and you all should be worrying about these things. The vast majority of us, let somebody else worry about it. We'll just use the hardware that's there, but it is worth understanding what the capabilities of these various specialized hardware components are so that we can ensure we're using the right thing. The next question, where are you going to run it? You've got a choice of a publicly hosted LLM. If you're a relatively small organization, this is probably what you're going to use. You're probably going to just figure out how it is I can use this in such a way that I will not disclose my client data and I will not disclose my intellectual property. But for a lot of organizations, that's simply not possible. But on-prem here does not mean you have a physical machine sitting in your room. This might be you're hosting it in your own cloud instance. It might be on-prem, but it might be your own cloud instance. There are lots of reasons for doing this. It may have to do with laws about where things can be hosted and where data can flow. It might be security. There are all kinds of reasons you might decide it's all fine and good for others to use OpenAI's model or Google's model, but I'm going to use one of the open source models that are available. I'm going to host it myself. And that way, I know what's going into it. I know how my data is being used and whether or not the training, what is happening with the inputs that I'm using with respect to training the model. And then the second question is, do you want to use just one of the foundational language models out there? Or do you want to use one of the other variants? The image generators, for example, are quite well known. But there are other specialized models that are using the same kind of technology. One of my personal favorites is there is a model that takes as an input a linear string of DNA and outputs target three-dimensional structures of that protein as it's been folded. And it's been trained on the relationships between DNA, or DNA sequences and three-dimensional models, but it's the same basic problem. I'm looking at what are the three-dimensional configurations of all of these related sorts of DNA strings, and what do I think a potential is for the three-dimensional structure of this one I've never seen before. The value of this model is it can dramatically reduce the cost of drug discovery. And part of the problem that we've had in the past with dealing with a lot of diseases that have been around for a long time is the pharmaceutical industry doesn't really have the financial incentive to invest that much money on some of these diseases. If we can dramatically reduce the cost to come up with drug candidates, we lower the cost of developing drugs and we increase the probability that we will actually start to attack some of these other diseases. A model like that is not going to help give you a William Faulkner story, but it uses the same basic underlying technology of training up a model in such a way that it can generate new instances based on the corpus that it has been trained on. So, critical question, where are you going to run and what kind of model are you going to use? And then we get to the model layer. Now, one of the things to realize, as step one, these models have essentially been built using the same data. They've all scraped all of the publicly available information, whether it be code or books or movies or photographs or Reddit posts, all of those different things. There is usually some kind of specialization level where a human gets involved. And obviously that's going to lead to some differences between the models because the humans are different. And the humans, even if they're given the same instructions, are not necessarily going to do exactly the right thing. So even though they have much the same training data, these models don't all behave the same. And you're going to want to try some of the different models that are available, if you can, to try to see which one is most appropriate for your use case and for your organization. You may decide you want multiple models. Sometimes that's obvious. Maybe some of what you need to do requires an image generator. And other parts of what you need, you want more text generation. So you might choose choose two models just because you have different uses you want to put them to. The next question you want to ask is, do you want an open source or a closed source model? There's actually still a lot of discussion going on what does it mean to open source a model? Is it the algorithm? Is it the parameters? Is it the training data? And there's a lot of effort being put into trying to understand what should you open source if you were going to open source a model. That being said, there are actually a significant number of open source models out there. The last estimate I heard was that it was those models are about 18 months behind the best of the closed source models. We talked a little bit about this on the previous slide. Is it a general purpose model? Are you looking for that general language capability, in which case you want one of the LLMs? Or are you looking for something more specialized? The next question is, do you actually want to build your application that is such that it is agnostic about which model it uses? This is roughly analogous to the question of, do you want to run multi-cloud, or do you want to specialize yourself to a particular cloud so you can take advantage of whatever specific features exist in that cloud? Because, as I said, these models aren't all the same. And so they're not necessarily going to respond in the same way. You may decide that you want to use different models for different purposes. You might, in fact, decide you want to be able to switch among models. And there are some tools that are available to help support switching amongst models. And then there is, again, the question of fine-tuning. Do you actually want to take one of these models and fine-tune it? Or do you want to use some other technique like RAG? Now, one of the more disturbing things I've read recently is that the model trainers have decided they're running out of data. Now, if you think of all of the estimates on how much new data we generate on the internet every single solitary day, the fact that they think they're running out of data is concerning. And so what they want to do is they want to start generating synthetic data using the large language models that they are then going to train the next generation on. That isn't an idea that I'm real comfortable with. You're taking something that, sure, it has a level of creativity in it, but most people, after they've seen some amount of responses from these models, they can look at some text and say, yeah, ChatGPT did that. If we then start training the next generation of model that ChatGPT is going to access, using output that everybody says, ooh, that looks like something ChatGPT did, we are going to start to degrade the quality of the output. We don't want that. In addition, like any reinforcement learning system, any biases that exist in that data, in the training data, are going to be reinforced and amplified if you start using synthetic data in the training. It's bad enough that just using those models does tend to amplify whatever characteristic, whether it be desirable or not. But if we're then going to use this to train the next generation of model, we run a risk of degrading the quality of the output of the model. So I'm hopeful that they're going to do a lot more research on, is this really a sensible approach to use this level of synthetic data? Now, one of the puzzles, and I haven't found an answer to this yet, so if anybody has heard this, I would love to hear it. A while ago, Sam Altman was reported as saying that he felt that the next significant leap in the power of the model would not come solely from an increase in the number of parameters. And much of the increase that we've seen in the past has been attributed to the fact that there's been an enormous increase in the number of parameters that the models can hold. And so the implication was that they're going to have to figure out, how do we supplement the current models and the current algorithms that work on those models to get that next leap forward in the power of the model? My hope is that if you take, gee, we're running out of data, with, gee, we need to rethink the problem a bit to get more power, maybe those things will cancel each other out. But this is something that I think it's worth people keeping an eye on. If we're actually running out of data, given the rate the world creates new data on the internet, that's a scary thought. There's all different kinds of tools that exist out there for different purposes in working with these different Gen AI systems. We recently put out our 30th edition of the Technology Radar from Thoughtworks, and about a third of the blips had something to do with AI and Gen AI, and many of them were tools that will help you perform various tasks. Obviously, there's the coding assistants, whether it be something like Copilot or whether it be something like the JetBrains enhancement of their IDE. An interesting thing around this in terms of coding assistance, one of my contentions is that if we're going to actually take advantage of generative AI, we have to fundamentally rethink our processes and how we do our job. Rather than saying, okay, these are the steps I follow, what can Gen AI do? We need to look instead at, this is the outcome that I want to achieve, how can AI help? In terms of category of tools, though, we obviously have the question answerers, the ChatGPTs of the world. Also, documents that answer questions, which is a very popular application I will talk more about. There are tools out there to help you build guardrails for privacy protection and monitoring the flow of data. And then, of course, we started with DevOps, and then we had MLOps, and now we have LLM ops. But it's just as important in dealing with large language models as it is anything else. We have to know how to deploy them. We have to know how to monitor them. We have to know how to fix them when they go wrong. We have to know how to evaluate how well they're working. And I'll talk more about that in the last section. And then there's applications. And of course, there's an enormous range of applications. We've been using AI for decades. Part of what's different now is that most of the AI you've interacted in the past with, you didn't think about the fact that it was AI. For decades, fraud verification on credit card transactions have been done with a neural network. You've been working with an AI system every time you use your credit card, but you didn't know it, and you didn't have to know it. One of the interesting implications, particularly of ChatGPT, is we have people who are interacting directly with AI systems that aren't AI researchers and that aren't computer scientists. We have lawyers and doctors and marketing people and construction workers, and pick your favorite. These are people who are using this incredibly powerful technology. I was speaking to a colleague of mine, and he said, yeah, I was in my doctor's office, and she says she's been using ChatGPT to look things up. And he was horrified and said, please tell me you checked on the answers that it gave you. But it is so easy to access this technology. I think that's both wonderful and terrifying. It's terrifying because people don't necessarily know the risks that they're running if they take things at face value. Case in point, lawyer who got sanctioned by a judge because he didn't check the ChatGPT's work. But wonderful because we don't really know the impact that this technology is going to have on all of these different applications. And having a broad set of people who are thinking about how can I use this technology to make my life better, that has the potential to open up a flood of innovation. I've always been very skeptical of innovation centers of excellence where you have these people, who are supposed to sit around and think great thoughts. I would far rather crowdsource ideas. And sure, eventually somebody's got to decide which ones to fund, but you want to bring them from as broad a place as possible. And the democratization of AI that has happened as a result of things like ChatGPT radically expands the source of ideas and how we might actually use this technology. But I put some sample applications up there. Obviously, apps supporting software development. And this is not just coding assistance. This can be generate me an outline of an organizational change management strategy. Give me some ideas on how I might structure a workshop. Show me how I might test an application with this particular features. These are all things that people are trying to do right now in supporting the software development lifecycle. We've probably heard the most about the customer service chatbots, particularly when you have things like Air Canada and their loss in the legal case. An interesting one that I've seen is to help the marketing department. There are applications that will generate comprehensive marketing plans. They will generate an image to support the mood that you want to set if somebody's looking at a display ad. They will generate an elevator pitch or the text that should go next to particular images to help sell your product. Now, of course, I would not take one of these and immediately send it to the metaphorical printer. But one of the nice things about these systems is they give you a place to start. One of my colleagues often has a horrible case of what I like to call blank paper disease. He's looking at a blank screen and has to write something and just can't get the first words out. He started using ChatGPT. And what's interesting is sometimes he really likes what's there and he just sort of fixes it up a little bit. But it's not all that uncommon that he hates what comes out. But what ChatGPT has done is put something on the screen. And even though he might delete the entire thing, it's gotten him over blank screen disease. Whatever works. One of the more interesting applications that we're seeing a lot of is effectively a document that answers your questions. So think about your employee policy guide. Isn't that so thrilling to read? But instead, you can load, through some of the techniques we'll talk about, that employee resource guide into a document answering system, and then you can ask, what is the specific eligibility period for the medical plan? And it will spit it out. And some of the better ones will not only spit out the answer, but they will give you the reference to where it appears in the guides, so you can actually go check it. People are also using something similar to this to start to analyze legacy code. You load up the legacy code and then you start asking questions about how it works, about how the information is flowing. Because what's one of the biggest problems of dealing with these legacy applications is you don't really understand how they work. And I'm beginning to think that these code models are actually better at explaining code than they are at writing it, which might not be a bad thing, by the way. One of my favorite applications, this is something that has come from Thoughtworks, but I think it demonstrates how you could integrate these models into a broader application. And Jugalbandi started life as an application here in India. The front end was a speech-to-text translation system that supported the Indic languages. The last number I saw that it's up to 11, but that was in January, and they've actually gotten much more efficient about supporting a broader class of languages. And it translates questions from people who are asking about the various welfare schemes that are available in India. And so consider a farmer somewhere who's using WhatsApp, and he can ask the question, what housing schemes am I eligible for? The speech to text will translate that. They will translate it into the base language of the documents that have been pulled from the Indian government website, using RAG to find the relevant policies, and then engage in a dialogue asking questions. Well, do you fall into this category? What is your situation here? And then presents to the person, this is what you have to do to be able to exercise your rights for this particular scheme. They've expanded it to include some other things having to do with the legal system in India. But you have RAG, you have speech to text, you have integration with various schemes out there where they can validate things. So it's not just ChatGPT. It's not just you have this gigantic model and you've got this very simple prompt interface and you're going to talk to it. You have a model that can serve as a critical component within your organization's IT assets. Okay, so let's talk about some patterns. Software architecture. This is a non-exhaustive list, but I think all of these have some relevance. If you're just going to serve a model that is going to ingest a prompt and respond to a prompt, a serverless architecture is absolutely the right way to go. And if you do some research, a lot of the performance improvements and tests and strategies are based on using a serverless architecture. But when you start looking at broader integrations, you might want to start considering a microservices architecture. If you think back to that Jugalbandi example, you've got lots of different moving parts going on there, and the model is clearly a critical part of that. But you've got different kinds of integrations to worry about, and so you'll probably want to consider to break up some of those activities into a microservices architecture. One of the more interesting things that I've seen with respect to privacy is pushing more and more of the serving of the model out to the edge. We'll train the model centrally, and maybe we'll use some of the techniques that are available to scale back a model, so you're not trying to send a trillion plus parameters to your poor mobile phone over your data roaming, which would be frightening. But instead, cut down the model, and then the interaction between the user and the model never leaves the user's phone. And so they have control over their data, but they're still able to take advantage of the power of the centrally trained model. So this is something we're starting to see more and more of, and I think that's going to continue. Now, I've talked about RAG. How many people are familiar with RAG? Okay, so a lot that aren't. RAG stands for Retrieval Augmented Generation. And conceptually, what you do is you've got this foundational model. Remember, that's my reserved word for what understands, in quotes. It's very easy to anthropomorphize these models, but it interprets the prompts and responds to those prompts. And you augment that foundational model with specialized content. Maybe what you have is your set of coding standards. I know of one particular application of this. A colleague of mine put together something. It was still a chatbot, but it was augmented with all of his individual writings. And so he used the RAG technique to effectively embed all of his writings, and then he had effectively a language system that would respond in his personal style. We all have a personal style. There are words that we use more commonly than others, more frequently than others. There are words that we don't tend to use at all. Some people always speak in very short sentences. Some people speak in much longer sentences. Some people have very plain language. Some people have very flowery language. And this chatbot responds like Mike. And all he did was use this technique to load up his writings, and now you have a melding of the language capabilities of the foundational model, but it is biased towards using Mike's voice. You can do that with all kinds of documents. I saw a recent paper where some people have also augmented the standard embeddings that you get in RAG with one example, in fact. It was an org chart. It was, these are the different organizations, the entities that exist within my company and how they relate to each other. And so the questions can be put into the context of where the question fits in the hierarchy of the organization. So there are all kinds of different things you can use this RAG technique for. Another very powerful software architecture approach is integration with other systems. One of the things I found reassuring about how Google was approaching some of its chatbots is when it came back with an answer, it came back with a link to where it found the answer or what it used to create the answer. And it made it a whole lot easier than to be able to check and see, okay, well, does this link exist or not? Because, ChatGPT makes things up. There's a Guardian reporter who has gotten multiple queries about how come I can't find your article online? And ChatGPT had properly identified this reporter as someone who wrote on this particular topic, and they made up the title of an article. And this one reporter got multiple requests like this. So having the ability to easily cross-check something is just one possible integration. Jugalbandi and the integration between the language model and the speech-to-text is another example of that, but there are numerous ones. Now let's talk about multi-agent systems. Everybody loves multi-agent systems. They're all the rage. An agent, very simply, is something that can take action outside of its context. And there are easy ways to do this, and there are hard ways to do this. And when you are looking at a multi-agent systems, particularly one where the agents act relatively autonomously, you have just bought yourself all of the potential problems of any distributed system. And you got to figure out how to address all those problems. So the topology of your multi-agent system matters. You might decide that you can conceive of a pipeline-like workflow where a problem is addressed in sequence by multiple models before it comes out at the end. By definition, that's a multi-agent system, but it's a relatively simple one to keep control of. If you start to get multiple layers, if you start to get lots of competing approaches to the problem, it's much more complicated. And you have to worry about the granularity of these individual agents. If you make them small, what does that mean? You probably have more of them. But if you make them small, it might be easier to understand, are they actually doing what I want them to do? Back when I was dealing with AI early on, there was something called a blackboard architecture. And that this idea has come back into favor. And conceptually, what you have is you have a blackboard. And I write a problem on the blackboard. And all of the students, the models, the agents, all look at the problem and decide, I know how to solve that. And they go off and come up with an answer, and they write their answer up on the blackboard. And then when we've either got, sorry, I'm stumped, or an answer from all of the different agents, then you can decide, do I want to take a consensus answer? Or do I like this answer better for whatever reason? And so that's one way also to approach a multi-agent system. But my recommendation is if you are early in your journey in dealing with Gen AI systems, try to keep it simple. One very simple use, and I'll talk a little bit more about this later, is to have one model check the answer of another model to decide whether or not it's a good one. That's a relatively simple interaction, and you won't get into too much trouble trying to approach that. But let's not make this problem any more complicated than it already is. Again, some of the prominent entities. Of course, this is a non-exhaustive list. But I do think one of the important ones that we have to at least understand what risks we are running is the non-determinism. We talked a lot about those other ones, but I do want to remind you that latency is a big deal. Just because our computers are faster than they were doesn't mean that they can respond at the speed that we would like them to respond, and that's something you have to take into account depending on how you're using the AI system. And I can't reinforce enough, yes, we do still have to care about observability, even if we don't really understand what it's doing under the covers. Now, one of the big problems that we're dealing with at the moment, 2023 was the year of the proof of concept. All kinds of organizations did all kinds of POCs across things that would go to their customers or things that would help support customer service or things that might help their sales organization or things that might help finance. We've got POCs all over the place. 2024 is the year they're trying to put those things into production. It's not going so well. The last number that I heard was in the high single-digit success rate, roughly 7%. That's pretty bad. Now, the kinds of problems are not surprising. We all know how easy it is to manually fix a lot of things when you've got a small set of users. These systems are no more immune to bad data than any other system is. And the fact is, most of our organizations, our data is not in a state that it can be properly processed. And so often, what these POC to production failures are highlighting is just how bad our data is. And so you have to go back to, okay, well, what do I have to do to clean up my data, to make sure the right people can see it and the wrong people can't, to make sure I know what it is, to make sure it's high quality data, to make sure ... Another part of this is, again, with a POC, who cares about having a nice automated flow to production? We don't need that for a POC. Well, you do need it if you want to put these things into production. And so a big problem that we're dealing with this year is how do we turn these POCs, and many of them have been quite successful in terms of validating their business case. What do we have to do to actually get them into production? Now, what about the poor architects? Well, it was bad enough before. When you think about the number of architects to the number of delivery teams, let alone the number of developers, the poor architects are vastly outnumbered. And now we've got coding assistants that are churning out more and more and more and more code. So we've made the problem for architects a whole lot worse. And oh, by the way, for things like refactoring, one study that I saw that was actually quite well done, the probability that the coding assistant got the refactoring right was 37%. That was the highest of any of the code models that existed. Now, how long do you think you'd keep your job if you got it wrong 63% of the time? Probably not very long. But what about coding standards? What about the enterprise patterns? How do I keep the integrity of the overall vision when I've got a code model spewing out code? And so we've made the problem for the architect much worse. But there are ways to handle it. First, let's talk about testing. Ponder for a moment, how would you write an automated test to test the validity of a non-deterministic system? There are actually some very well-developed metrics for things like natural language translation, but those metrics have not proved useful in evaluating the quality of some of these models. We're still playing with lots of different ways to validate this. Some of it is asking the language model to suggest tests that you might then run against the other language model. This might be that paired language model where one model checks the answer of the other one. We're also seeing a lot of red teaming going on in terms of trying to expose particular kinds of vulnerabilities in these systems. This is exactly the same kind of red teaming you see in security, except it's targeted at how can I make the large language model do something it's not supposed to do. And jailbreaking is, again, something that is getting a lot of attention, as I said earlier, given the size of the context window. We just can't handle it. Standards, we can use techniques similar to RAG to load up what our enterprise standards are, so the model won't generate stuff that we don't want it to. And that's just one of the approaches. But AI and Gen AI are completely reshaping the entire software delivery process. And we need to think about what that means for our jobs, and we need to think about what that means for the jobs in 20 years. And as a reminder, this will be all out of date by Monday. Thank you very much.